Welcome to the Year 12 PPE question 9 about the cosine graph. In particular, we have the function y equals 4 cos x. Okay, and it's sketched for us here. We've got to answer a few questions about this point P here. Okay, well, we should know that the 4 in front of cos x causes the minimum to go as low as -4 and the maximum to go up to 4. So we know that d is -4, and we should know that this is negative 90 degrees. The low point is at negative 180. This is negative 270, and so on. Okay, so using that information, let's write down that C is negative 180 and D is negative 4. Okay. Now, in question B, we're applying some transformations to our function 4 cos x. And this time we're dividing x by 4. This has the effect of stretching the function by a factor of 4 from the y-axis. Okay, so instead of being at -180, it's now -720, 4 times further away, and that stays as it was. Okay, this function here causes the graph to translate 48 units to the right. So it was at -180, it's now at -132, negative 4. Okay, very basic transformation of graph questions from GCSE really. Now for part C, we've got to solve this equation for the range of values of theta between 450 and 720. So what I'm going to do is start to change this into one form, either sine, cos or tan. And this is going to change into sine, and you'll see how in a moment. 4 cos theta equals 7 sine theta over cos theta. Okay, you must use these trig identities because they help you convert in the way that we're doing now. Okay, and if I multiply both sides by cos theta, I get 4 cos squared theta equals 7 sine theta. And now I need to note that 4 cos squared is the same as 1 minus sine squared theta. Okay, using the identity sine squared plus cos squared equals 1. Okay, if I take that and multiply it all out, I get 4 minus 4 sine squared theta minus 7 sine theta equals 0. Okay, multiply everything by -1 and I'll get 4 sine squared theta plus 7 sine theta and -4 equals 0. Okay, now that is a quadratic obviously in sine theta. It won't factorize, so I'm going to use the quadratic formula, and I get that sine theta, okay, is equal to -7 plus or minus the square root of 49 minus, well, it's 4 times 4 times -4, so it's 49 plus 64. Okay, all of that has to go over 8. Okay, 2 lots of 4. And just be very careful using the quadratic formula, and especially with the minus signs. And that gives you 7 minus 7 plus or minus root 113. Okay, over 8 And that leads to two solutions, one of which may not be valid, and in fact that proves to be the case. So sine theta from here is equal to 0.4537 or negative 2.2 something. Okay, so clearly that second one we ignore because it's out of range. Now we need the values between 450 and 720. So it's a slightly unusual range, but I'll pull in a little graph of sine theta and show you how best this works. If we take the principal value, okay, or the primary value off the calculator, let me go back to that again, that will give me 0.45 is just, so this is 1, this is 0.5, so 0.45 is about here, okay, and you can see if I project this right across to here, okay, the principal value that you get off the calculator is that theta equals, I'll come across here now, so it gives me that theta equals 26.98, okay. Now I know that it also equals 360 plus that or 720 plus that, okay, so it could easily be 746.98, okay, because basically the sine graph restarts, if you like, every 360 degrees. Now we've got 720 on our little sketch, okay. Now if you look at the symmetry of the graph, you can see how it would move back from here, okay, and it would come over to here, and that distance there is going to be 26.98 back from 540. So this value we want is here, and it's the only one, okay, that's the only value we want because it's in the range 450 to 720. Okay, so this comes from the value we need for theta, which is 540 minus 26.98, okay, in fact 27 to because I think we only need to give it to one decimal place, yes, so that would be 27.0, so I'm just going to put 27.0 there, and that's going to give me 513, okay, and strictly speaking we should write 513.0 degrees to 1 dp, okay, and that is the correct answer. That's the only value of theta. Okay, so an unusual problem because of this range that they're giving us to answer within. Okay, that's it.